Welcome to The Explainer. Today, we are getting into a really fundamental problem that's become a major bottleneck for the next wave of AI. It's such a big deal, in fact, that it's forcing a total reinvention of the data centers that power our world. And it all comes down to one thing: memory.
So let's start with this vision from NVIDIA's Jensen Huang, because it just nails it. This really sets the stage for what we're talking about. See, we're moving past simple question and answer bots. The real goal now is to create an AI that's a genuine collaborator, one that actually remembers you, learns from you, and builds on everything you've talked about before.
So what do we call this new kind of AI, the one that needs this incredible memory? Well, it's called Agentic AI, and believe me, it is a massive leap beyond the chatbots we're all used to.
You know how a typical chatbot has the memory of a goldfish? It forgets your conversation the second it's over. Well, Agentic AI is the exact opposite. It has persistence. It can juggle multi-step tasks, use different software tools, and even plan ahead. It's like upgrading from a calculator to a digital assistant that can run an entire project for you. But it's that very persistence, that need to remember everything, that creates a massive technical headache.
And this brings us right to the heart of the issue: the AI memory problem. I mean, for an AI to have a memory, that memory has to live somewhere, right? And that, my friends, is where things start to get really complicated.
So here's the bottleneck. It's a technical thing called the KV cache, but just think of it as the AI's working memory, kind of like its scratch pad. Now imagine having a conversation where, before you could say your next sentence, you had to reread the entire transcript of everything said so far, every single time. That's what the AI does with its scratch pad. And with Agentic AI, that scratch pad gets so big so fast that the hardware just can't keep up.
And this perfectly shows the impossible choice developers are stuck with. On one side, you have the GPU's own built-in memory. It's like a Ferrari, unbelievably fast, but it's also got a thimble for a gas tank. It's tiny and super expensive. On the other side, you've got shared storage. That's like a massive tanker truck, tons of space, but it moves at a crawl. You're stuck. It's a classic catch-22.
If you look at the memory layers we have now, the problem is crystal clear. You've got G1, that super fast GPU memory, but it's just too small. Then there's G2, the main computer RAM, a bit bigger, but still not enough. So you're forced to go all the way out to G4, the slow shared storage. But grabbing data from there takes milliseconds, which in computing is an eternity. It leaves these multi-million-dollar GPUs just sitting there, twiddling their thumbs, waiting for data.
So, what do? You're stuck with this massive bottleneck that's literally baked into the hardware. You can't just make the old stuff bigger or faster. You need a completely new way of thinking. So what was NVIDIA's big idea?
This was the billion-dollar question. The industry had to figure out how to bridge this giant canyon between speed and capacity. They had to invent something new, a middle ground, a Goldilocks zone designed for one thing and one thing only: the very specific needs of AI memory.
And the solution is actually pretty elegant. They basically invented a whole new layer, what they call a G3.5 tier. Now, the technical name is a mouthful: Inference Context Memory Storage, or ICMS. But forget the jargon. What it does is simple and brilliant. Think of it like a smart butler for the GPU. It anticipates what data the AI is going to need, fetches it from the slow storage ahead of time, and has it ready to go, so the GPU is never left waiting.
And this isn't just a faster hard drive, no way. This is a whole specialized system, almost like a dedicated air traffic control tower just for AI memory. It uses super fast flash storage, and it even has its own little processors, these Bluefield 4 things, to manage all the data traffic so the main computer doesn't have to. The result? A massive pool of shared memory where that AI scratchpad, that KV cache, is finally treated like a VIP.
Okay, so it sounds great on paper, a really clever design, but what does that actually get you in the real world? What's the payoff? Well, the performance numbers are kind of wild. First off, speed. By getting rid of all that time the GPU spends just waiting around, this new system can churn out up to 5 times more tokens per second on those big, complex tasks. What that means for you is that the AI can think and respond much, much faster. But here's the real kicker: it gets that massive speed boost while also being 5 times more power efficient. How is that possible? Well, because it's a specialist. It was custom built for this one job, so it cuts out all the wasted energy you get from using a clunky, general-purpose storage system. And that huge gain in efficiency you're seeing, that's not just a nice little bonus. It translates directly to a lower total cost of ownership.
It means for every dollar you spend on power, more of that energy is going into actual AI thinking, not just shuffling data back and forth.
So, let's zoom out. What we're seeing here is way more than just a simple hardware upgrade. This is a fundamental shift. It's forcing us to completely rethink how we design and build the data centers of the future. The old blueprints just won't cut it anymore.
So if you're an IT leader, here are the big takeaways. First, you have to start thinking about this AI memory, this KV cache, as a totally new class of data. It's temporary, but it is extremely sensitive to delays. Second, your software has to get a lot smarter about the physical layout of the data center to keep things running efficiently. And third, get ready for more power density. Because this approach is so efficient, you can pack more AI into the same space, and that means you're going to need to seriously plan for more power and more cooling.
So the big takeaway is this. The old model is broken. The whole idea of building data centers with the fast computers over here and the slow, big storage way over there, that's officially obsolete. It just can't keep up with the future of AI, which needs memory that is fast, vast, and right next to the processor.
And that really leaves us with a final thought to chew on. Building the future of AI isn't just about writing smarter code or training bigger models. It's about fundamentally redesigning the physical buildings and the hardware that house these new digital minds. The next great leap for AI might not happen in a software lab, but in the physical architecture of the data center itself.